A very good afternoon to all of you. I am Dr. Preeti Soni, Assistant Professor of Chemistry in Government GNA PG College, Bhatapara, Chhattisgarh. I am presenting here my research paper, which topic is Journey of Fly Ash from Waste to Best. The abstract is the present paper deals with the study of fly ash utilization as it is considered as problem, but there are certain ways to change the problem into a solution. The fly ash produced as a result of burning of Indian coal has tremendous potential to be utilized for different applications, and in this paper I am trying to show you that the fly ash is a waste but it has now turned into a best. The introduction is fly ash is a heterogeneous byproduct material produced in the combustion process of coal used in power stations. It is a fine grey colored powder. You can see in the picture I have given below, having spherical glassy particles that rise with the flue gases. As fly ash contains pozzolanic materials components which rich with lime to form cementitious material, thus fly ash is used in concrete, mines, landfills and dams. Now the application of fly ash. The fly ash can be used in various ways, as it can be used as a prime material in many cement based products such as poured concrete, concrete block and brick. One of the most common uses of fly ash is in Portland cement concrete pavement. Road construction project using PCC can use a great deal of concrete, and substituting fly ash provides significant economic benefits. Fly ash has also been used as an embankment and minefields, and it has increasingly gained acceptance by the Federal Highway Administration. Now, as I want to show you that there are several benefits of fly ash, the fly ash can be a cost-effective substitute for Portland cement in many markets. Fly ash is also recognized as an environmentally friendly material because it is a byproduct and has low embodied energy, the measure of how much energy is consumed in producing and shipping a building material. By contrast, the Portland cement has a very high embodied energy because its production requires a great deal of heat. Fly ash requires less water than Portland cement, and it is easier to use in cold weather also. Now there are several benefits which includes produces various set times, cold weather resistance, high strength gains depending on use, can be used as an admixture, considered a non-shrink material, produces dense concrete with a smooth surface and sharp detail. It has greater workability, reduces crack problems, permeability and bleeding. It also reduces heat of hydration. Allows for a lower water cement ratio for similar slumps when compared to fly ash mixes. It also reduces CO2 emissions used in the manufacture of Portland cement. Typically it is used for embankment construction also, used as a soil stabilization material, and it is also used as a component in the production of flowable fill and as a filler mineral in asphalt road to fill the voids. Here you can see the images, the uses of fly ash as bricks and also as a fertilizer. Now with benefits there are some disadvantages too, that too also we cannot ignite. Smaller builders and housing contractors may not be familiar with fly ash products, which can have different properties depending on where and how it was obtained. Additionally, fly ash applications may face resistance from traditional builders due to its tendency to efflorescence, along with concerns about freeze-thaw performance, and other concerns about using fly ash are slower strength gain, they are seasonal limitation and increased need for airs in training admixtures. Now you can see some images about the uses of fly ash in percentages. What percentage of fly ash are used in various purposes? In the past, the fly ash was generally released into the atmosphere, but air pollution control standards now require that it can be captured prior to release by fitting pollution control equipment. In the past, the fly ash produced from coal combustion was simply entrained in flue gases and dispersed into the atmosphere. This created environmental and health concerns that prompted laws that have reduced fly ash emissions to less than 1% of ash produced. Worldwide, more than 65% of fly ash product produced from coal power station is disposed of in landfills and ash ponds. The recycling of fly ash has become an increasing problem or concern in recent years due to increasing landfill cost and current interest in sustainable development. As the survey result of 2017 says, coal-fired power plants in the US reported producing 38.2 million short tons, of which 24.1 million short tons were used in various applications. Environmental benefits to recycling fly ash includes reducing the demand for virgin materials that would need quarrying and cheap substitution for materials such as Portland cement. Here I have minimized the use of or recycling of fly ash into a grout and flowable fill production. It is also used for waste stabilization and solidification, in cement clinker production, in mine reclamation, in stabilization of soft soils, in road subbase construction, as aggregate substitute material, mineral in asphaltic concern, and agriculture uses like soil amendment, fertilizer, cattle feeders, soil stabilization in stock feed yards, and agricultural stake. It also has loose applications on rivers to melt ice. It is also used in some other applications including making of cosmetics, furniture, toothpaste, kitchen countertops, floor, ceiling tiles, bowling balls, tool handles, picture frames, auto bodies, and boat hulls, etc. PVC pipes are also made up of fly ash nowadays. Now, here we can see the conclusion part. The conclusion says that the coal contains trace levels of trace elements such as arsenic, barium, beryllium, boron, cadmium, chromium, thallium, selenium, molybdenum, and mercury also, many of which are very highly toxic to humans and other life. Therefore, fly ash obtained after combustion of these coal contains enhanced concentrations of these elements, and the potential of the ash to cause groundwater pollution is very significant. So now we can see from the past to present that fly ash, which was a waste, now turns to be into the best. In the past, fly ash is pollutant and contaminant, and its large scale production is also have a storage and disposal as a big problem. But as the time flows, our researchers are deliberately going on how to use the fly ash in better ways, and successfully they had found about many ways for utilization of fly ash in better ways. Fly ash is having a high optimum moisture content, high permeability, low shear strength, and low compressive strength because of the permeability of the sample for the fly ash to be utilized. So now I can say that the fly ash, which is concerned as a waste material or pollutant or contaminant, now it is a best material to be used in various purposes. So here are the references from where I have done my work, and thank you all for listening me.